Hello guys, in this video I'm going to talk you through how to find the equation of a straight line when you're told 2 points that it goes through. So for the first one, we're going to have this point here and this point here, and we're going to find the equation of the straight line that goes through those 2 points exactly. Now for this example, I'm going to do it just both algebraically, and then I'm also going to show it to you on the coordinate grid. But just bear in mind that if you got this in a GCSE exam, you wouldn't have the axes to help you. You would have to rely on just the algebraic process. But for the two examples I'm going to show you in this video, we'll have it with the axes so you can see how the algebra relates to the picture. So the two coordinates that we've got here are the coordinate 6, 4, that's this one here, and the coordinate 8, 10. The first thing you have to do is find the gradient. Now, you might already have a method that you like for finding the gradient between 2 points. If you don't, I have made another video on how to do that, which you can look back on first. Any of the methods is fine, whichever one works best for you. I'm going to do 2 different methods for each of these examples so you can see both of them, but you choose whichever method works best for you. So for the method I'm going to do for this one, I'm going to use the ratios. So I'm going to think about the journey from this coordinate to this one. From 6 to 8 is a gap of 2. So to go from here to here, I'm going to have to go 2 across from left to right. And to go from 4 up to 10, I need to go 6 up. So I'm thinking 2 across and then 6 up. Now, in order to find gradient, I need it to be 1 across going from left to right. So I'm going to need to divide this by 2, and I'm going to need to divide this by 2, and I get it to 3 up. This number is now my gradient, which I call my m value. Okay, so I can say m, or gradient is 3. Now, a straight line equation is in the form y equals mx plus c. That's what our answer is going to look like, but with a number filled in there for m and a number filled in there for c. So far, I know the m value is 3, so I can put that in straight away. Y equals 3x plus something. Now, what I'm going to do next is I'm going to use one of the coordinates. You can use either one, it doesn't matter. I am going to use this one here because the numbers are smaller, but it will work either way. So 6 is an x value and 4 is a y value. And what I'm going to do is I'm going to put the 6 in where the x is and 4 where the y is. So I'm going to have the y value equals 3 lots of the x value plus c. So the y value is 4. I'm going to pop that there where the 4 was. And the x value is 6. I'm going to have that multiplied by the 3 because that's where the x was. I'm now going to work out what I have. So I'm going to have 4 equals 18 plus c. And I'm going to solve for c. So I'm going to subtract 18 on both sides. 4 take away 18 gets me down to negative 14. So that's my c value. Now that I know my m value and my c value, I've got enough information to get my equation. And remember, the equation is in the form y equals mx plus c. So I just need to say what my m and my c value are within that equation. So it's y equals 3x minus 14. That is the answer. Okay, so step 1, find the gradient. Put that gradient into the equation, and then next up you're going to put the x and y value from one of the coordinates in, solve for c, and then make sure you give your answer with both the m value and the c value in your equation. Before we move on, I'm just going to draw this line so we can check that our gradient is 3 and our y-intercept is minus 14. Okay, so here is our line. I took my original 2 coordinates and drew a line through them. Now you'll notice if we look at one of the steps on this line, if we go 1 across and 3 up, we get back to the line. So 1 across, 3 up is where my gradient came from. And if we look at where the line crosses the y-axis, down here, it crosses at minus 14. Sorry, you won't be able to see that, but it says minus 14. So that y-intercept there at minus 14 is where that c value comes from. Okay, so that's why that is my equation. Just bear in mind in a GCSE paper, you won't have a graph to check it on, so you'll have to rely on this algebraic method to be confident enough with it that you are right. I'm now going to do a second question. Given two coordinates, I'm going to find out what the gradient and then the equation is. Okay, so for this one, I'm going to use a slightly different method for finding gradient, but you can keep using the across and up and down one if you prefer. I'm going to use y2 minus y1 over x2 minus x1. Now, this method is fine as long as you make sure that your y2 and x2 are from the same coordinate and your y1 and your x1 are also from the same coordinate. If you find that you're frequently getting your minus numbers wrong on this, or just getting the values wrong, I would go back and use the other method because it's a bit more intuitive and there are less opportunities to make a mistake with this. So I'm going to treat this as my second coordinate and this is my first coordinate. So my y2 is going to be minus 18 and my y1 is going to be 2. My x2 is going to be 3 and my x1 is going to be minus 1. You'll notice I'm always subtracting even if it's a minus, so I'm writing minus minus 1. Okay, so make sure you write that down and then think carefully about the negatives. So negative 18 take away 2 gets us down to negative 20. Minus 3 take negative 1. Well, taking a negative is the same as adding, so we're doing 3 plus 1, which is 4. So my gradient is minus 20 divided by 4, or minus 5. That is my m value. So I now know if my equation is in the form y equals mx plus c, I know that I need to put the minus 5 in there with the x. So y equals minus 5x plus c. So same idea as before, just a slightly different way to find the gradient. Once we've got the gradient, we need to use one of the coordinates, just like we did last time. So I'm going to use this coordinate here because the numbers are smaller, but you can use the other one, it doesn't matter. That's my x, that's my y. So putting them into the sum, I'm going to have my y value equals minus 5 lots of my x value plus c. You'd be amazed how many people get them the wrong way around because you have to put them the other order than they appear in the coordinate. So y is 2 and x is minus 1. So 2 equals minus 5 times minus 1, which is positive 5 plus c. 2 equals 5 plus c. To solve that, I'm going to subtract 5 from both sides. 2 minus 5 is minus 3, so c has to be negative 3. So my equation then is y equals minus 5x minus 3. And that is my final answer. Okay, so it's quite a long-winded process. In a GCSE exam, you will get marks as you work through those. So the further along you get, you'll get marks at this point, and you'll get marks at the substitution point, and then again at the answer point. I'm now going to draw this line on our axes so we can see how the gradient is minus 5 and the y-intercept is minus 3. So minus 1, 2 is going to be there, and 3 minus 18 is going to be all the way down here. So we're now going to join them up and see what our gradient and y-intercept come out as. Okay, so here we are. I've drawn that line on. Apologies, you might not be able to see the numbers, but this point here is 3 below the x-axis. So this is y is minus 3. So that's our y-intercept. And if we do a journey, if we start, say, here and go 1 across, 1, 2, 3, 4, 5 down, we get to our line. So we can see that the gradient is minus 5, because it's going downwards. Okay, so that's the process that you need to follow. Whichever method you use for finding gradient, first step, once you've got the gradient, you put it into that form of the equation. You're going to need to substitute in an entire coordinate, get your c value, and then put that into the answer at the very end. Okay, so here's one more question. What I'm going to suggest you do is pause the video and see how far you can get, and then I'm going to talk through gradient, then I'll talk through the substitution bit, and then I'll do the final answer. So you can get as far as you can, or you can try each part of it and then pause it and have a go. So if you're going to try the first section, you want to find gradient between those 2 points first of all. Okay, here's how to find the gradient between those 2 points. I'm going to do 2 different methods to find this. So First method, I'm going to think how far across and then how far up or down I go. So from 2 across to 5, I'm going 3 across in this direction. From 7 down to -8, I'm going 15 down. I need this to be 1 across, so I need to divide by 3, do the same over here, and it's 5 down. So my gradient, because it's going 5 downwards, is going to be -5. The other method is using y2 minus y1 over x2 minus x1. If this is my x2 and my y2, and this is my x1 and my y1, I then put the numbers in the right place. So it's going to be -8 minus 7 over 5 minus 2. -8 minus 7 is -15. 5 minus 2 is 3. -15 divided by 3 is -5. So my m value is -5. Once you've got the gradient, you need to think about what you know about the equation y equals mx plus c and use substituting a coordinate. Okay, so on to the next step. We know already that our gradient is -5. So I'm just going to take away the working out because we know that already. So I know that my equation is y equals -5x plus c already. Okay, I'm going to substitute in one of the coordinates. I'm going to choose 2, 7 because both of the numbers are positive, which makes life a little bit easier. So this is my x and this is my y value. So I'm going to have my y value equals -5 times my x value plus c. My y value is 7. My x value is 2. So 7 equals -10 plus c. I need to add 10 to both sides, and I'm going to get 17 as my c value. The final step is writing down your final answer. Okay, so my final answer, I know my m value is -5, and I know my c value is 17. So my final answer is y equals -5x plus 17, or you can also write that as y equals 17 minus 5x if you prefer. Okay.